So today we're going to discuss about static routing. So in this case, we're going to discuss about static routing. We'll configure static routing in default routes, and we will try to see to some extent the default summary. So how do we reach a remote network? So when we say a remote network, it's a network which is not under our control. So let us say this is a router. You have another router here. So let us say there are connections this side. So this is network 1, network 2, network 3. So let us say this is router 1 is the network. So this is router 1. So router 1 will have a control over 1 and 2, network 1 and network 2. So these are IP addresses, but it doesn't have a control over network 3, which is controlled by router 2. So learning about this network can be for router 1 because it's not under its control. Learning about remote network 3 by network 1 can be manually learned. We can configure it manually, or router 1 could learn this remote about network 3 dynamically. So manually we can learn it, or dynamically by the exchange of information between router 1 and router 2. Router 1 can learn about network 3. So manual configuration and dynamic learning, it's the same with regard to DHCP configuration. It's more or less similar with that one. So why do we need to use a static routing? So static routing is manually configuring the static routes. So why do we need to do that? We need to do that because first, we might not want so let us say that there are the advantage of static routing over the dynamic routing. Why? Because static routes are not advertised. If they are not advertised, the networks will not be known by other users to intrude into your system. So the first issue is better security because your network would not been advertised. That means router 2 is not going to advertise about network 3 to router 1. So that's one of the advantages. The second advantage is the usage of resources, limited resources. So you're going to use lesser bandwidths because there is no advertisement, and also there is no CPU cycles being used so that for calculating and communicating summaries. So this will provide resource usage. So limited resource will be used in the case of static routing. Another one is that your path is known. So you do know where you are going to send the path that are going to be taken by the static routes is known. So that could be. So there are also is a disadvantage. One of the disadvantages, it's especially when you configure it initially, it's time consuming. It's maintenance and configuration in the first, because it's done by the human, it's error prone. But in the case of dynamic learning, the routers by themselves will configure it. Another one is administrator intervention is required whenever there is route change. So because it's manually configured, whenever there is some kind of problem on that route, you need to change that route. So in that case, administrators need to be intervened. So they need to intervene and reconfigure the route. So if you have a growing network, so if you expect that your network is going to grow in the future, the static route does not scale well with your network. So in that case, it will become very difficult to configure even static routes in the first place. So you need to know about the whole network. So you need to have a knowledge about the whole networks, because otherwise you cannot manually configure it. You need to have which router exists, or which network exists in which router, in which path. So this kind of information are required. So this makes it using static routing very difficult. Static routing will have three main uses, which we indirectly have talked about. The first place is if you have smaller networks. So if you have a smaller network, static routing can easily be configured. So, but if you expect that your network is going to grow significantly, static routing is not recommended. But if you have a smaller network, you can use it. And also, whenever you have a stub network. So if you have a stub network is usually have only one-in-one link with another router. So in that case, you are not expected to make it static routing, dynamic routing, because you only have one. If you have one path, why do you need in the first place to make a connection? Why do we need to have any? For example, you can see it here. So you can this is a stub network. So this is the network that has the only one network address, and there is only one exit interface to another network. So here you have another network. So this network is only connected to this router. In this case, you are not expected to configure on the router one. So router one does not need to configure all, because you have only one route here. You don't expect it static routing to reach. So to reach, whenever you have stub network, because usually it have only one network, so you don't expect to configure it dynamic routing. Even providing it, that would be not a recommended one. So these cases make it. The third one is whenever you have a single default route. So we said about the stub network, we did to go to a small network. So default route. So default route, what is the default route? Default route represents whenever you don't have a matching. So if a router could not find the matching for the network, so in that case you are going to use what? Static routing. Because you need to configure what kind of route? Default route. Default route means an exit point whenever the destination IP address that you want to send does not exist in your network. So in that case, default routes will be used by what? By static routing. So those three will be. So static routing will be used to reach the specific network. When we say with the gateway of the last resolve in the stub network, and also in the case of static routing, we can summarize several contiguous networks as a single one static route. So one static single route, we can say it's just summarization. We can use summarization whenever you have, if in case there is a route failing, or if one of the routes fail, then in that case you can create a backup route. So whenever there is some kind of failure on one of the networks, then you can use this as a backup route. So you can create using static routing. So we say that this is stub network. So what is the default route? Default route is the route that matches all the packets. It matches all the packets. So it can be used for default route. So the default route is the route that matches all the matches all the packets, because it have this kind of IP address. So the IP and the subnet mask is both of them are 000. So what is the default route? The default route is it's what? It's a gateway. An exit point. An exit point for all packets that does not have what? That does not have not been learned, or that does not have a static route. So if your router does not have a static route for IP packets, or if it has not learned that IP packet, then that can be used as a default route. So we call it a default route. So a default route is whenever, so let us say, anyway, whenever there is a network that network does not exist in the network that you have configured, or if it doesn't exist in the static route configuration, then you can use it in the. Here you can see what do we see here? Summary rules. So in this case, you are seeing summary. So when you configure this IP's address, or when you end this IP address. So in the case of ending all this IP address, you'll get a commonality of this IP address. So you can see that maybe this one is a little bit a mistake. I think it is 127. That's a mistake. It should have been 172. But just in case, when you calculate the common number from this one, you'll get this number. This is their commonalities. So because you do know that 20, 21, 22, 23, all of them are, this is 20. 20 is what? 20 is 0, 0, 0. So 1, 0, 0. Then 0, then 0. So this is 20. So this is 21, let us say. What is 21? 21 is equal to 0, 0, 0, 1, 0, 0, 0, 1. This is 21. So when you calculate the common numbers between these two, so when you end them, you will get 0, 0, 0, 1. When you end them, then you'll get this number. So what is this one? You can see, I think all of them have this one, sorry. So this is their common number. So what is this number? This number is 20. So that's why we got, so this is, we call it summary route. So how do we write the command? The command can be written with this format. So this is static routing. We'll say IP route, where we'll provide the network address of a network and the subnet mask and its exit point. So we have the network address of the network that we are going to, the destination network of the remote network. So the destination address of the remote network, and you have the subnet mask. So we can, here you have the next hop. The next hop can be identified by either IP address, or by the exit interface, or by the pose. So that's what we call the next. One of them is the next hop. So the first one is an IP address. The second one is an interface, an exit interface. The third one is both IP address and exit interface together. So now you can see here the next hop static. So in this case, the next hop static route, you can see, for example, if here you have 172, this is the configuration of router 1. So directly connected ones are what? 172, 16. So, but here you can see this is the static routing. So this is the static route. How do we get to the static route of 172 so 192.168.2.0? How do we get to this network? By going through which interface? This interface, this one. What is this dot 2? That is 172.16.2.2. So this is what we call it the next hop. The next hop is an IP address. So this is the next IP address. So to reach to this network, you need to go through this IP address. So you need to go through this IP address. That's what we call the next hop. So the second one is, so you can see that here you are configuring it through what? An exit interface. So the second step was what? Interface. So exit interface. So now previously we used what kind of mechanisms. So for example, you can see here router now. We can say that we can reach this network, and this network, because they are all of them are remote. They are not known by router 1. Router 1 only knows these two networks. So these other all of them, this one is also remote for router 1. This is also remote for router 1. This is also remote for router 1. But these are this one and this one are directly connected. So they are called C. This C that you see are directly connected. So how do we access to this network? To reach this network, you need to exit through this interface, the serial 00. This interface, we call it what? An exit interface. So this one is an interface. If it is an IP, you are going to provide it the directly connected remote IP address. If it is going to be the exit interface, so you are going to provide it your own interface. So when it is an exit interface, the interface, you are not going to use the remote one, but if it is an IP address will be the remote IP address, this IP address. So what is this IP address? 172.168.16.22. That's the remote directly connected remote IP, and this one is the exit interface. That's the difference between those two. Sometimes we might use fully specified static route. In this case, we're going to provide both. What do we provide? We'll provide both the interface and the next hop IP address. So in that case, we're going to use both of them. We're going to use this interface and also this IP address. So this IP address and this interface and this IP address will be combined. That's when we call it the next fully specified. So if it is fully specified, both you need to have an IP and an exit interface. So how do we verify? You can verify usually with the usual command is the static IP route. If you use this command, if you see an S, if you see some command that's called S, that's called static route. So what about default route? What is a default route? Default route means, let us say, it's a kind of a route where you are going to use, for what purpose? You are going to use it. You are going to use it for what purpose? You are going to use it for the purpose of what? Whenever you don't have a network address that does not match on your network. For example, let us take this one here. So all these networks will be known with each other. If it is dynamic, they can communicate easily. If it is static, you need to specify it explicitly, like this one. For example, router 1, what are the 3 networks that the router 1 does not know? This one, and this one. So you need to specify these 3 through this mechanism. You will say IP route, you will provide network IP addresses, then you will provide the subnet mask for each one, and then you are going to provide the exit interface. How can router 1 reach to this one? It can reach through this one, through this interface. It can reach to this one through the same interface. It can reach to this network through the same interface. So you are going to go this way and this way and this way, the same paths, through the same exit interfaces. So that's what we're going to do. But let us say that you have network. Let us say that you have here, you don't have an exit interface. You don't have a mechanism to go out to the outside world. Let us say that here you have the service provider. So here you have the service provider of your country. So here you have the service provider of your country. So in this case, what do we do? So we have, let us say, this is the network of the service provider, which is connected to this one. So this path, we call it what? An exit interface. Why do we say an exit interface? Whenever you have something which is not, let us say, for example, google.com. Google.com. Do you think google.com exists in this network? It doesn't exist in this network. So how can you reach to this network, to google.com, if it is not available in this network? So always you need to prepare some exit interface, that we call it an exit, to reach to this net. To go to this network, every packet which has not been destined in your network will be sent to the exit interface. That's what we call an exit interface, or default route, sorry. So previously we said that the IP address and subnet mask of default route is 000.000, and you can provide just like an IP address or the exit interface like the previous one. So this means any packet. So we can provide these two. For example, now you can see now the exit interface to this network is what? This is the exit interface. So if you ping google.com from here, it will be sent to this interface. So if a known network is pinged or tested from your network, that message will be sent to the exit interface. But if it exists in your network, it can directly be sent to that one. So you can see that whenever you see this asterisk, that's what we call it, what? The exit interface. The exit interface is which one? Is this one. So this will be used as and call it what? The gateway of last resort. So it is the last exit point. By testing every network, if your network does not exist, that will be sent to that one. So another one is summarization. Summary, static route summary. I think I have already said that. Then you'll end all these values. So when you end with this is the binary representation of this one, and the same this one. When you end them, you can see that or not ending. When you make exclusive OR, yeah, usually there exclusive ORs are used. So you can see that when you combine them, this is 0, this is 0, this is 0. So until you can summarize their IP. So you can see that the commonalities between these three numbers are up to this one. Here you can see that this is 0, this is 1, this is 1. So in this part they are different. At least the first one is different. But up to this point, all of them have commonalities. Then you will take that number, the number which are common up to that point, and you'll count their numbers. How many of them? There are 22. Then you'll make it /22. Previously it was /24. Now their common number will become this one, and their subnet mask will be this one. So this number is called what? The summarized number of these three. The summarized number of these three. Just you don't take these commonalities because this seems common. It's not common here, because there is some difference number between this number and this number. There should not exist some differences. You'll start from the left and you'll go until you see the first difference, and then you'll stop. So you can see here at the top it is 0, then it is 1, it is 1. So this is not going to be. So this is going to be their summary, and then you'll make the rest 0. So you can see that the rest will become 0. Then you'll take that number and you'll make it. So how do you troubleshoot? So in order to troubleshoot, you can use any of these commands. These commands are so common, you need to remember all of them. You need to remember them. The ping is very critical. The trace route is very critical, so that it will enable you to trace from the source to the destination, step by step, router by router, interface by interface. So this is a very, very important. Show IP route is also very critical whenever you are using routing protocols, whether it is static or dynamic. And show IP interface brief is very important whenever you want to see a very well summarized interface report when you're doing that. So don't forget all of them. So CDP neighboring is also can be used for network neighbor discovery. So these all of them are very critical and important. So why do we need all of them? So that whenever there is a missing or misconfigured route. So if you have a missing route or misconfigured route, so you are going to use either the ping command or the trace command. The ping command is usually you can ping it through the single interface. Traceroute would reveal us step by step. So this is a very important, you can now investigate it, the routing table. So for example, here you can see what? Yeah, router 1 is pinging what? It is pinging router 3's interface, the GIG00 interface. So they are trusting this one because this is dot one is this interface. So you are testing this one. So it says what? The response is 0. What does it mean? It means router 1 cannot access this interface of router 3. So there is a problem either here or here or here or here. Neither of the paths. There is some problem. You need to check that one. So in general, static routes are used, can be configured using what? Using the next hop address, and you can also use the exit interface. So whenever you have point to point, so when we say point to point, it's just like the stub network. So whenever you have one router here, if it is connected, directly connected with another router through a single network, this kind of connection, we call it point to point. In this kind of network, static routing is the recommended approach rather than dynamic routing, because you don't have many cables translating, going from this one to this one. But whenever we have a multi-access network, what does it mean? Multi-access network means whenever you have multiple devices connected to some device, in that case we can use also static routes can also be used in that case. So static routes usually will have administrative distance of 1. Thank you very much. So we'll go to the configuration part in the next video. Thank you very much.